All right, we're ready to do the last problem from Learning Workbook, page 169. It says, given f of x equals the sum x plus 10 squared for the domain bracket negative 10 comma infinity, find f inverse of x. State the domain of f inverse as an interval. Okay, our previous video was on the shorter side. This one's going to balance things out and be a little bit on the longer side. Let's go ahead and begin. The first thing that I would like to point out to you is something that I mentioned in the previous video. Whenever you're asked to find the inverse of a function, it has to be a one-to-one function. So let's think about that. Is this function a one-to-one function? Remember your transformations techniques. Let's say you have this function, f of x equals the sum x plus 10 squared. That's very similar to the quadratic function f of x equals x squared, but there's this plus 10 in there. That plus 10 is inside close to x, which means there's been a horizontal transformation. Adding or subtracting is indicative of a shift, so this must be a horizontal shift. Horizontal is the reverse of what you would expect, so this plus 10 is not to the right, it's to the left. So the graph of this function is just our parabola, our quadratic function, shifted 10 spaces to the left. Let's create a quick sketch. The vertex is here at negative 10, and then the parabola opens up from there. Now, you can only find the inverse of a function if it's a one-to-one function. And if you remember the skills that I taught you in previous videos from this section, the way you determine if a function is one-to-one is by applying the horizontal line test. And if you apply the horizontal line test to this function, you're going to find that that horizontal line intersects it at more than one point. And you might be thinking to yourself, so that must mean it's not one-to-one and therefore there is no inverse. But that would make this problem unsolvable. And certainly Alex would not give you an unsolvable problem. So that's where this domain component comes in. We can't use the function based solely on its equation. We need to provide a domain restriction, which means we're only going to use the part of this graph where the x-coordinates are from negative 10 to infinity. You can think of this kind of like an inequality. X has to be greater than or equal to negative 10, which means my function now kind of feels like a piecewise defined function. It's almost like I had the word if thrown in there. So this part of my graph has to be amended. I'm going to cut my graph right here at negative 10. And then since this says greater than negative 10, I'm going to keep the part to the right. So all of this goes away. And now, suddenly, I no longer have a problem with my horizontal line test. It turns out the function that they gave us was a one-to-one function all along. Whew. Okay, so now that we have that established, let's see if we can go ahead and determine what f inverse of x is equal to for this problem. The domain restriction will be part of our algebra. Step 1, turn f of x into y. So then we have y equals, parenthesis, x plus 10, close parenthesis, squared, with the restriction that x must be greater than or equal to negative 10. Step 2, turn all x's into y's and all y's into x's. So then we'll have x equals, parenthesis, y plus 10, close parenthesis, squared, and even this x gets turned into a y. So now we're going to have y is greater than or equal to negative 10. This is worth talking about for just a moment. X greater than or equal to negative 10 was a domain restriction. But when you turn x into y, it turns domain into range. And so now our problem has a range restriction. Y has to be greater than or equal to negative 10. All right, step 3, solve for y. All right. So we need to find a way to get this y by itself. Well, we're going to use a property that we learned way, way back at the beginning of this semester. I'm going to swap the sides of these two, of this equality, just for a moment, because I think this will make it just a little bit easier for you all to see. And we're going to use the square root property from way, way back at the beginning. All right, when you have something squared equals something, you can, on the left, drop the square in the parentheses, if, on the right, you put plus or minus square root. So we'll have y plus 10 equals plus or minus square root of x. And now by subtracting 10 on both sides, we get y by itself. So y is equal to negative 10 plus or minus square root of x. We still have our domain, our range restriction. Y is greater than or equal to negative 10. Okay, now this next part requires a little bit of thought, so stay with me. Y is equal to negative 10 plus or minus something. But we know that y has to be greater than or equal to negative 10. So let's say you're at negative 10 and you add something. Well, then you're going to go up and you're going to be greater than negative 10. That's okay based on this range restriction. Y has to be greater than or equal to negative 10. But let's say you're at negative 10 and then you subtract something. Well, then you're going to go down and then you will no longer meet this requirement. Here's the point that I'm making. If y really is going to be greater than or equal to negative 10, then that means we cannot subtract something. So we're going to use this information to get rid of the subtraction symbol in our problem. So this is going to give us y is equal to negative 10 plus the square root of x. We now no longer write an inequality because it has done its job, which is to get rid of the minus part of the plus or minus. And finally, step 4 is to turn y into f inverse. So f inverse of x is equal to negative 10 plus the square root of x. All right, great. First part of this problem is now done. We found f inverse of x. Now the only thing left to do is to state the domain of f inverse as an interval. Okay, so let's see if we can go ahead and accomplish that. The first thing that I would like to point out to you regarding this particular problem is the equation that we're dealing with. Negative 10 plus the square root of x. We can create a quick sketch of this because it's actually going to make it just a little bit easier to determine our domain if we do that. So watch this. Negative 10 plus the square root of x. That's the square root function, just shifted down vertically 10 steps. So that means it's going to look like this. Okay, this is a picture of our new function, f inverse of x. And then based on that picture, we can very easily see our domain. Domain is a collection of all of the x's. So this is the smallest x, which is 0, and this arrow indicates the largest x, which is infinity. So the domain goes from 0 to infinity. Now there's another way that we can come up with this answer, which is we can just apply the 4 steps for finding domain to this function. You know, start with all real numbers, even radicand greater than or equal to 0, log arguments greater than 0, denominators not equal to 0. Well, we don't have any log arguments or denominators, but our radicand is x. So x has to be greater than or equal to 0. As an interval, that gives us bracket 0, comma, infinity. So you can see all of the concepts that we've learned previously are woven together in this one problem. So there were 2 questions and there are 2 answers. The first answer is find f inverse of x. We get negative 10 plus the square root of x. The second question was state the domain of f inverse. That's the interval bracket 0, comma, infinity.